This video is a demonstration of some basic procedural audio programming in Max MSP or pure data. What we see here is the finished version of a module that will select a series of chords and play them randomly according to a predefined tempo or random tempo as we choose. On the red module, we have an on-off button that triggers the metronome. Below that button, there is a tap tempo that allows us to define a manual value for that metronome. We can also choose to make the metric of the compasses fixed or randomized. This metronome will play random chords that are included in a predefined list of possibilities. There is also an option to enable a melody that will improvise with notes of the scale that includes the chord. Below that box, there is a randomizer for the velocity of each note that the melody plays if we wish to add more dynamism. On the green module, we can find a little piano that will trigger different preloaded samples for each note we play. These samples can also be triggered by the same common metronome with a specified or random value. We will begin with the left part, where the on-off button switches the metronome. When we open the patch Metro, we see the first inlet where the on-off trigger is set. I chose to play a little with these options, so to turn the Metro on, instead of just using a box, I chose to use the cycle object to only emit a bang when both numbers are matched, so the only way would be double-clicking. When activated, the Metro is set to 500 by default, but on the second inlet, we see a tap tempo that can send alternate values. This tap tempo patch works with a timer object, which calculates the time between bangs. The two first values that the subsequent cycle receives are averaged by adding them and dividing them by 2. Going back to the Metro patch, when we have the tempo set and we turn it on, it sends triggers to a counter. This counter will send 1, 2, 3 and 4 to a cycle object set up with 4 parameters and will sequentially send a bang to the different bangs that light up. The first bang or light will be linked to another counter that will control the sampler, which we will talk about later. Go into the chords section. There is a gate object which inlet is connected to the counter object sending 1 to 4 at the rate of the metro. There is a conditional object that establishes that it sends a bang every time the counter gate receives a number 1. This would be each beginning of the measure, 1 every 4 beats. Every time a bang is received by the chords patch, a random object sends a random number between 1 and 7. This number is sent to a call object which has the 7 chords of the C key preset. This will be sent to an iter object which will separate the numbers individually that will be sent to the MIDI channel. The melody patch is a bit tricky. The chords patch sends the index number of the chord that is being played to a similar call. All the 4 notes of the chord are going to be split into separate numbers by the unpack object. A prepend object is assigned to each output value to avoid writing the index number into the new call. So basically, what this is doing is rewriting the new call object every time a new chord is played. On the right side, because the priority of the trigger goes from left to right, there is a random object, sending random numbers to be used as the indexes that refer to the notes to be played in the melody. The set of objects on the right randomizes the metric of the metro. The patch expression randomizes the velocity of the notes. When the metronome sends a bang to the counter, its output alternates between 1 and 2. This makes the switch alternate between one or the other range selected for that velocity. The sample player is a simple module that can either be triggered by the samples individually or be automatically triggered by the tempo input.